Am I audible? Sir, shall we start?
Yes, yes, yes.
Good evening, sir, and all my fellow mates who are presented over here. This is Aman Sharma. I would like to welcome you all on the behalf of the Adali in our today's geography class by highly respected Sandeep Mahajan, sir. Let's begin our journey of creating a masterpiece through the art of geography. Without any further delay, let's start the class by a positive and wonderful quote. Education is the passport to the future, for tomorrow belongs to those who prepare for it today. Thank you. Now I would like to request you, sir, please continue the class. Over to you, sir.
Thank you, sir.
Thank you.
Good evening, guys. Good evening, everyone. Just a small thing. I hope most of you have attended morning session because it will be continuation of morning session. Else, it will be like you will feel lost in the process. Okay. Now, guys, I was talking to you about troposphere. In troposphere, we observed that if we have Earth, layers closer to Earth will be hotter. And as I go above, it will be cold. Because of three reasons. One, density is more near the surface. Second, water vapor is more. And third, Earth is the major source of heat for atmosphere. Based on these three aspects, I told that with increase in height, temperature is going to reduce. Now, my point is, can you people tell me what is the height of troposphere? NCRTs, if you have read. What is the height of troposphere? 8 to 13 kilometer, good. 15 to 15, no. 8 to 13. 8 to 13, okay. Is it 8 or is it 13? Why 8 to 13? About 16, 13, overlapping near poles. Varies according to latitude, good. Near poles and equator, good. Okay. Everyone, for just 2 minutes, observe this carefully. Let me assume this is 90-degree north. 60-degree north. Ma'am, if you attend clarity won't be there, ma'am. It's better to see that video and then see now. See guys, now if I take 0 to 30 degree, this is my tropical region. And as it is tropical region, it will be generally hot. This will be polar region and it will be generally cold. This is my temperate region, which is normal. Now, let me assume I have same level everywhere. I have same level everywhere. Now, as tropical region is hot, land will be hot, air will be hot. And if there is hot air expands. And then this. This is cold. If I have cold air, contracts. So, one region air is contracting, another region air is normal, another area air is expanding. So if I see the height will change. It is 8 kilometers near poles, 18 kilometers near equator, 13 kilometers near temperate region. Average height is 13 kilometers. So guys, remember this. What here we are observing that as troposphere is under the influence of the earth. And if earth is hot, air expands. If earth is cold, air contracts. And because of this, height of troposphere is not same everywhere. Height of troposphere changes from poles to equator. That is, it increases from poles to equator. Is this clear, guys? So you tell me now, can we say that height of troposphere changes with latitudes? Height of troposphere changes with latitudes. Yes. See guys, I just told you, hot air expands, cold air contracts. So as it contracts, height decreases, here height increases. So this is what we are trying to tell. Now, second thing is, let me take seasons. You people tell me summer season, will the temperature increases? Earth's temperature increases. If the temperature increases, can we say that height increases? Yes. Winter season, can we say height decreases? So can you tell me, does troposphere height change with latitudes, and do they change with seasons? Correct? They change with both latitudes and they change with seasons. Yes, good. Now everyone, second point. A, B and C. Guys, A, B and C, D, E and F. Normally, guys, if A is 30 degree, B will be 15 degree, C will be 0 degree. Let us assume. Then, ma'am, summer means temperature of the land increases. As temperature of land increases, height increases. Every height increases. Winter means land will be cooler, height decreases. Right? Cool means height decreases, hot means height increases. So now, if I look at this is 0, but at D, the temperature is minus 45 degrees Celsius. At E, temperature is minus 54 degrees Celsius. At F, temperature is minus 65 degrees Celsius. Actually, as we go above, temperature keeps decreasing. So in this diagram, if I check, A, that is equatorial temperature, is greater than poles. Equatorial temperature is greater than poles. And if I check here, poles temperature is greater than equator. See guys, near the ground surface, equator is hotter compared to poles. But near tropopause, near the height of tropopause, poles are hotter compared to equator. And what is the reason? As we move above, temperature decreases. Here it is 18 kilometers. 18 kilometers means temperature will be very less. Here it is 8 kilometers means temperature will be moderate. So because of this, in NCERT, they will give you two lines. What are the two lines? The height of troposphere changes with latitudes. It changes with seasons. Second, surface temperature near equator is greater than poles. Similarly, upper air temperature of poles is greater than equator. Upper air means D, E and F. That is what we are talking about. Can you make a note below? Height of tropopause. You're writing note, you wrote first note, you write second note. You write second note. Temperature of troposphere temperature of troposphere depends on Earth's surface, depends on Earth's surface, because if Earth is hotter, it will heat the air above, through conduction. Then if Earth is cooler, then air above will also be cooler. Then air above will also be cooler. Full stop. Next point. On the surface of the Earth, temperature changes with latitudes. Temperature changes with latitudes. Full stop. As temperature changes, height of troposphere also changes. Next paragraph. The height of troposphere changes from 8 to 18 kilometers. 8 to 18 kilometers. Full stop. Near poles, it is 8 kilometer. And near equator, it is 18 kilometers. Next point. The average height of troposphere is 13 kilometers. 13 kilometers. Next paragraph. In summer season, Earth's surface temperature increases. Earth's surface temperature increases. And during this, average height average height of troposphere, average height of troposphere increases. Average height of troposphere increases. Next point. During winter season, Earth's surface will become cooler. Earth's surface will become cooler. And average height reduces. Thus the height of troposphere, changes with latitudes and seasons. Next point. Surface air temperature near equator is more compared to poles. Next. Upper troposphere temperature near poles is greater than equator. Let's draw this, guys. No, ma'am. Greater than equator. We are talking about upper air temperature. T will be greater than F. This tropopause is a transition layer. We'll come to it. Next, we'll talk about that. Okay. CC, ma'am. E value is -54. See, as we go above, temperature decreases. Normally it decreases at minus 6.5 degrees Celsius per kilometer. So if I go 8 kilometers, temperature decrease will be less. And if I go 18 kilometers, temperature decrease will be more. You can say 18 into minus 6.5. Here 8 into minus 6.5. So what is going to happen? Temperature of D is minus 45, temperature of F is minus 65 because of the height. I'm just taking ABC, that's it, guys. Don't worry what is ABC here. They're just points. Yes. So guys, let's take up next one. That is see, now we did about what we call as Earth's surface. And from Earth's surface, we spoke about troposphere. Now, when we talk about stratosphere, before discussing about tropopause, let us look at stratosphere. Now, if we look at stratosphere, in stratosphere, there is something called as ozone. And what we observe in stratosphere is there is a huge ozone below, and as I go above, there is one small layer of ozone. Fine. One area you have huge ozone, another area you will have a small ozone layer. Fine. Now, ozone doesn't absorb Earth's radiation. So it is not under the influence of Earth. Fine. Stratosphere is not under the influence of the Earth. Now let us talk about sun. Now when we discuss about sun, ozone, this is also ozone, this is also ozone. But closer to the lower stratosphere, I have thick ozone. Upper stratosphere, I have thin ozone. Both will absorb UV. Both will absorb UV rays. Now, let me just take a scenario, guys. There is a small tumbler filled with water, and there is a big tumbler filled with water. When I heat this, and when I heat this, right? Both are water only. Both are water only. and both are same temperature, right? Both are water only and both are same temperature only. Now, let me assume this is A, this is B. Can you people tell me which tumbler gets heated fast? A will be heated fast, B will take time. Ma'am, if I have a very big tumbler and if I heat it, it will take time to heat. If I have a small tumbler and if I heat it, it will take less time to heat. So A will take less time, B will take more time. A will become hot, B will be cooler, B will be cold. Okay, so this is basics, guys. A very big tumbler if I take and if I heat it, it will take lot of time to get heated. Small tumbler, quickly it will get heated. Here also, a small layer of ozone, forget about what is there. See, it doesn't have any impact of the earth, correct? Earth radiation is not absorbed by ozone. So it is only with respect to sun. That's the first point I told. Earth doesn't have any role in heating the ozone. Ozone is purely under the control of sun, right? Temperature of ozone. Now everyone, if you look back into your notes, can you see and tell me if cold is below, hot is above, will there be vertical movement or no vertical movement? No vertical movement. Good. So if there is no vertical movement, can there be horizontal movement? At least, yes, yes. So in stratosphere, there is no vertical movement and there is no, there is no vertical movement, but there is some horizontal movement. Second, guys, you see, 99% water vapor is present in troposphere. Okay, guys, these are all facts. 99% of water vapor is present within troposphere. That means in stratosphere, number of clouds will be less. It's not zero, but number of clouds will be less. Now you tell me, if clouds are not there, if vertical movement of air is not there, can we say that the region is good for aircraft movement? Yes. So in prelims, they asked a question, why do you have aircraft movement in stratosphere? One answer was no vertical movement of air. Second was no clouds. Yes, you tell me now, is it no clouds or less clouds? Is it no clouds or less clouds? This is wrong. This is correct. You should be very careful, guys. When you look at the words, you should be very, very careful. Do you understand now this particular thing? Yes. Can you write? Can you write stratosphere? In note only you write this. At last I will give you how to write answer. See, I'm dividing this into two parts, guys. Atmosphere I'm dividing into two parts. As of now, I'm teaching you all prelims oriented. At the end, I will combine them and help you to write a mains answer. Fine. First, let us finish off prelims point of view. So you write below stratosphere. In note only, you write stratosphere. No, ma'am. We do not have any specific reason for that. But that's a good question. No idea why it is accumulated only in that. Stratosphere. Below that, guys. Within stratosphere, comma, lower stratosphere has thick ozone. Lower stratosphere has thick ozone, and upper stratosphere will have thin layer of ozone. Next point. Ozone absorbs UV part of the sun's rays. Ozone absorbs UV part of the sun's rays. Full stop. As thin layer absorbs quickly, it will be hotter compared to below layer. Next paragraph. In stratosphere, with increase in height, temperature increases. With increase in height, temperature increases. Because of this, there is no vertical movement. Because of this, there is no vertical movement. Next. There will be horizontal movement. Within stratosphere. Next. In stratosphere, there will be less clouds. Full stop. Due to these reasons, aircraft can fly easily in stratosphere, But stratosphere height may reach till 50 kilometers. Okay, now everyone look at this. In troposphere, A will be hot, B will be cold, C will be cold, D will be hot. So here there is vertical movement. Here no vertical movement. One side I have vertical movement, another side I do not have vertical movement. See this, I have two different layers. Now I want you people to tell me, let us say air is rising like this. Now if the air wants to enter into stratosphere, air cannot enter, mainly because in stratosphere vertical movement is not there. So whatever air will go after hitting this, either it will go like this or it will go like this. It will not go above. So all the air, that means if I release pollutant, right? Let us say we released a pollutant. All those pollutant will go till here, will turn and come back. But it will not go to stratosphere, except CFC, which goes and attaches. That you will read in environment. So as of now, just remember it doesn't go. So one layer there is convection, another layer there is no convection. So when we have two different layers, obviously there will be a transition layer, and this transition layer is called as tropopause. Yes, anywhere if I have a transition layer, that is like, one layer convection is there, another layer convection is not there. When I have a transition, then normally what is going to happen? There will be a transition layer. And guys, here pause, we use the term pause. Pause basically means something is becoming constant or same. So tropopause, stratopause, mesopause means temperature is becoming constant or almost constant. So temperature will become almost constant. From upper layer is hot mainly because their stratos ozone is small and it absorbs the sun's rays, that is UV rays, and it becomes hotter. So that is what we taught here. So now this is what we see. Fine. In this we also check another important thing, you know that height of tropopause is not same. It changes with latitude. So here I told you the temperature will be minus 45, minus 54, and minus 65. And now, here it will be minus 45, minus 54, minus 65. So in this region, temperature remains constant. Fine. The value remains constant. It's not everywhere, but from troposphere to stratosphere, temperature remains constant. This layer is my tropopause. Yes, ma'am. Can you write tropopause? Tropopause. Hyphen. Yeah. Ma'am, how is there a horizontal movement in stratosphere? Normally, what happens? Uh, whatever air comes, whatever air is there, right? It is observed that from equator to poles, we normally observe that there is some sort of movement. That's why we say in stratosphere, some horizontal movement is there. We observe some air movement is. Yeah. Tropopause, it is a transition zone. It is a transition zone between troposphere and stratosphere. It is a transition zone between troposphere and stratosphere. Next point. The height of tropopause, varies with latitudes and seasons. With latitudes and seasons. Next paragraph. Within tropopause, temperature remains almost constant. Okay. So now, guys, troposphere is done. Stratosphere is done. A and B. See, guys, thickness varies from 1 to 1.5 kilometers. And we all read here it is minus 54 degrees Celsius. And here it reaches 0 degrees Celsius. 0 is hotter compared to minus 54 degrees Celsius. Now, this is near the earth. This is 13 kilometers average. This is 50 kilometers. Above this, I have a layer called as mesosphere. Can you people tell me, will we have more air particles or will we have less air particles in mesosphere? Less. Can we say most of the air particles are present within this itself? Yes. Now you tell me, as I go above, here I have more air particles, here comparatively less air particles. Because as we move above, density decreases. Only in stratosphere, because of ozone, we saw change. But if stratosphere was also not having ozone, with increase in height, temperature would have decreased everywhere. Now, when I look at this C and D, it is said that multiple explanations are there, guys. Two explanations I'll give you. One explanation is that C is closer to ozone. So C will be warmer. D is away from it. D will be cold. Guys, you tell me now, if at all very less particles are there, can we say if air is expanding, it will become very cold? If it is closer, it will be warm. One reason. Second reason, what are we talking here? C is closer to ozone, D is away from ozone. So I will have warm here, cold here. Can you people tell me, will there be convection or no convection? Will there be convection or no convection? Guys, cold air above, warm air below will lead to cold air coming down and warm air rising. But remember, as particles are very less, it is negligible convection. I'll give a very simple example. You see here, I have a tumbler filled with water and I am heating it. And I have another tumbler, very less water, and I am heating it. Here, water circulation is visible. Why? Clearly I can see some water is moving. But here, that water circulation will not be visible. Similarly, in mesosphere also, air circulation will be very, very less. Why is there less air circulation? Because of less particles. Because of less particles. Guys, then NCERT says only in troposphere convection is there. But in other layers, convection is almost absent. Is that true? Is that true? Convection is almost absent. Is correct. See, in troposphere, convection is more because more air particles are there. But in mesosphere, convection is very, very less. Now, I want you people to tell me, guys, I'll give temperatures. This is 30 degree. And here it became minus 54 degree. Here it became 0 degree. And here it became minus 80 degree. Ground 13 kilometers, 50 kilometers, 80 kilometers. Guys, in the entire atmosphere, only in mesosphere, temperature is reaching minus 80 degrees Celsius. If temperature reaches minus 80 degrees Celsius in mesosphere, it is the coldest layer of the atmosphere. Which layer is the coldest layer of the atmosphere? Mesosphere. Mesosphere is the coldest layer of the atmosphere. Yes, ma'am. Ma'am, particles are very less. As particles are very, very less, temperature will be extremely cooler. It is neither absorbing sun's rays, nor it is absorbing earth's rays. Because of that, it will be comparatively cooler. Now, everyone, if we go to poles, ma'am, cold means temperature, ma'am. It doesn't mean whether it will have more particles or less particles. Let me say I have a small ice cube, I have a big ice cube, doesn't matter. Temperature will be same. Then I will call it cold. In one condition, cold may have more air particles. In another condition, cold may have less air particles. So cold and hot should be seen only from temperature point of view, not from number of air particles point of view. Yes, Devanshu, it's right. So guys, now let us go to poles. If we are in the poles and if we rub our hands, due to friction, can I say my hands will become little warmer? Yes. So you tell me, my hands are becoming warmer because of friction or because of surrounding temperature? My hand is becoming warmer because of friction or because of surrounding temperature? Friction, correct. So similarly, this is the coldest layer. This is the coldest layer. Now, in this layer, some air particles are there. So let me say meteor. Okay. A meteor enters into troposphere. Let us say 100 meteors entered into mesosphere. At least 80 will burn in mesosphere only, and 80 will burn in mesosphere because of friction. 80 will burn in mesosphere because of friction. So, mesosphere, we will observe meteor burning. In mesosphere, we will observe meteor burning. Guys, in stratosphere also you will observe. In what you call troposphere also you observe. But most of it will be burnt in mesosphere. So in that layer, we observe meteor burning. Aeroplane can go in troposphere. Aeroplane can go in stratosphere. But in stratosphere, it is very good. It is like this. Clear? Yeah. Guys, meteor burns. Meteor burns. Am I audible?
Yes, sir, you are perfectly audible.
Guys, friction is there because of air particles. Friction is there because of air particles. Okay. Can you write? Mesosphere. Mesosphere. Why rockets launched from Earth does not burn in mesosphere? We use the metals to ensure that it is not burnt. We have stratopause. I'll come to that. Air particle is present in every layer. See, but from where is the mesosphere coming? Sorry, from where is the meteor coming? Meteor is coming from the space. So when it comes, first it will encounter mesosphere. First it will encounter mesosphere. Then it will encounter stratosphere. Then it will come to troposphere. So what happens? First layer where little bit more air particles are there, that will burn. And for those, okay, let me take a minute and explain it differently. See this. If I take the Earth, troposphere, stratosphere, mesosphere, thermosphere. Right. Now, thermosphere particles are not there at all, almost not there. Very, very less. So, meteor doesn't burn. Then a meteor comes to mesosphere. In mesosphere, little more particles are there. So friction will be there. Stratosphere, more particles. Friction increases. If it comes, it will break. Troposphere also more air particles. Here also it will burn. But majority will be burnt in mesosphere only. In the first layer only if it is burnt, in below layers you won't get it. That is what we mean to say. Clear? Panavat, I think we saw meteor, meteoroid, asteroid. I'll explain it if not. Okay. You write mesosphere hyphen. In this layer, number of air are very less. Next point. Because of this, am I not audible?
So now you are audible, better lagging on your voice.
Okay. No, I didn't go mute, but I think there is some internet fluctuation. Yes. Okay. Just a minute. What you wrote? Okay. First point is in mesosphere, number of air particles. Yes. I'm repeating the first point, you write. In mesosphere, number of air particles is less. In mesosphere, number of air particles is less. Second, as density decreases with height, as density decreases with height, temperature also decreases. Temperature also decreases. Full stop. Temperature would become minus 80 degrees Celsius. Minus 80 degrees Celsius. Temperature would become minus 80 degrees Celsius, and it is the coldest layer. And it is the coldest layer. Next point. Meteor burn in this layer. Meteor burn in this layer due to friction. Due to friction. Next point. If there is water vapor, if there is water vapor in the meteor, if there is water vapor in the meteor, then it will form clouds called as noctilucent clouds. Then it will form clouds called as noctilucent clouds. Next point. In between stratosphere and mesosphere, we observe stratopause. In between stratosphere and mesosphere, we observe stratopause. Full stop. The height of stratopause the height of stratopause remains the same, it doesn't change with latitudes, it doesn't change with latitudes or with seasons, Amrita, I do not remember exactly the flow, so I think some of your friends will help you out. Guys, take 5 minutes break. We'll start. Guys, everyone, did you understand some basic points? Forget about, see, two things, guys. I am trying to give reasons for everything. In exam, they might not ask you reasons of everything. But to ensure you have some understanding, we are drawing diagrams and we are doing it. But some basic points that you must remember is, in troposphere, with increase in height, temperature decreases. In stratosphere, with increase in height, temperature increases. In mesosphere, with increase in height, temperature again decreases. And then comes our most important layer. If I say this is my mesosphere, above that I have a layer called as mesopause. Guys, if I go to mesopause, air particles are not there at all, right? No. We'll come to thermosphere. In thermosphere, ionosphere will be there. Solar flare can pass through any layers. Now the basic thing that I want you people to understand here is, above mesopause, air particles are almost absent. That means if we go there, we don't feel anything. We don't feel anything. We don't feel air at all. Because particles are like, if one is here, another one is here, and the distance is approximately 100 kilometers, or it may go to 1000 kilometers. That means what? One particle and another particle distance is very far from each other. Because of this, we really don't know what is the temperature. Why? Because temperature is degree of hotness or coolness of a body. What is temperature? Degree of hotness or coolness of a body. But in the layers above mesosphere, there is no air at all. There is no body at all. If body itself is not there, temperature impact will not be there at all. Sir, then is there no temperature? Like, almost no temperature. You don't feel hot, you don't feel cold, because air itself is not there. Then why are we interested in this layer? Because in this layer, if I say this is mesosphere, I have in one layer lot of ions. Lot of ions are there. And as ions are there, this layer is known as ionosphere. And what happens? Earlier, we used to send radio signals to this layer. And if we send radio signals, it used to send back. See, it goes and comes back. And it was helpful for radio communication. The ions were helpful for radio communications. But you ask your parents, nowadays it's not there. You ask your parents, earlier if they have to get a TV signal, or if they have to get, like, what you call as a radio signal, what they used to do, they used to change the frequency. Like, experts were there, they used to go change it, and then they used to listen. And like, TV also, they used to go above, they used to turn antennas, they used to turn and then get the signal. Now what happened? We observed that this layer is still 400 to 600 kilometers. Fine. As you have 400 to 600 kilometers, like, ISRO and all have launched satellites. This is called low Earth orbit satellites. Low Earth orbit satellites. And satellite will be at one place. As satellite is at one place, what is going to happen? The communication is established effectively. Right? So today, in this layer, we observe spacecrafts. Spacecraft. And above this layer, we will have exosphere. This exosphere will go till 1600 kilometers, guys. Exosphere will go till 1600 kilometers. Guys, ionosphere and exosphere together is called as thermosphere. Ionosphere and exosphere together is known as thermosphere. Yeah, ma'am. Now, in the ionosphere region, we are sending satellites, ma'am. If we send satellites won't move with the wind. So because of that, it is stable. As it is stable, we receive signals effectively. Today, we need not go and turn the antennas because we are not communicating with the wind or ions, but we are communicating with the spacecraft. Okay. So guys, now can you write one last point? Write one last point. Thermosphere. Hyphen. It extends from 80 kilometer till 1600 kilometers. It extends from 80 kilometer till 1600 kilometer. Next point. This layer will have different gases and also ions. And also ions. Next point. In between 80 to 600 kilometers, we observe ionosphere, which are ions, layer, which is helpful for radio communication, Full stop. Today we observe low Earth orbit satellites in this region. Low Earth orbit satellites in this region. Next point. Beyond 600 kilometers, low Earth orbitals, RISAT, all such. Beyond 600 kilometers, we observe exosphere, extending till 1,600 kilometers. Extending till 1,600 kilometers. Have you heard about Gaganyaan? We are planning to launch Gaganyaan to ionosphere only. We are planning to launch Gaganyaan to ionosphere only. We are not going very far. We will be here only. Yes. Now, guys, everyone, I will give the diagram that you have to draw. I'll reduce the video for a while. I want everyone to draw this properly. This is 10 marks or 15 marks question. Here I am going to write about temperature. -80, -70. Draw this clearly, guys. In troposphere, guys, temperature will become minus 54. Here it will become 0. Minus 80. So here decreasing, increasing, decreasing, and some geographers say even here it increases. Particles won't be there, but still they say it increases. And in this layer, you will observe convection. Clouds formation. This is a layer of ozone. And in this layer, we can see aircraft movement. In NCRT 6 standard and all, they will show an aeroplane here. In this layer, we observe meteor burning. Here, we will observe satellites. Yes, in exam, if they ask you structure of atmosphere, mandatorily, you need to talk about two things. One is height, guys. Right? You need to talk about height of every layer. Second, how temperature changes in every layer. Aircraft, meteor burning, all this is exception. But these are mandatories. Please draw this. Yes, if it is done, you can leave. If it is done, you can leave. Others can wait. You can write. Tomorrow morning, we'll deal with two aspects, guys. Composition of atmosphere. And then we will talk about temperature. Yeah. If you are done, you can leave. Tomorrow class time they will send this. Yeah. If there is any suggestions, you can text me. If any student is facing any problem, you are open because this is online platform. So won't be able to understand many aspects. Guys, ozone is more above also, ozone is more below, ozone is less above. You see here, this is what we told now. So basically our understanding will be, if it is thicker, it will be more. If it is thinner, it will be less. But the point is, look at this. A very big tumbler, I am heating at same temperature. A small tumbler, I am heating at same temperature. This one will become very hot. This one will take time. So this one will be comparatively hotter. This one will be comparatively cooler. So that's why I gave the tumbler example. Air doesn't allow conduction, guys. But wherever air touches the land, their conduction will be there. Yes, ma'am. Anything, if you find difficulty, please go through lectures again. Even after that, if you are not understanding, you can text me. I'll call and explain. Okay, guys, we'll leave. Ram, you're right. Due to friction, definitely, stratosphere has more friction compared to mesosphere. But meteor is not coming from stratosphere to mesosphere, but it is coming from meso to strato. So in meso only, if it is burnt, nothing is left to be burnt in strato. See, first I will enter into a room. I will kill 90% of the germs. Nothing is left for the next room. So whatever comes from here, if it is burnt here only, nothing goes to this layer. Okay, guys. Thank you. Thanks a lot.
Thank you, sir.